Okay, good morning class. We are on to Mamu with Jarvis, and this morning we'll be looking at geometry. If you look at the topic on the board, it says cylinder and cones. There are many areas we have in geometry, but we'll be looking at one area. We call that area mensuration. What does mensuration mean? It means that we are dealing with what? Measurements. We're dealing with what? Measurements. So the big question is, what kind of things can we measure? So we're dealing with measurements. As it pertains to shapes. So we're dealing with measurements, not just measurement of anything, not measurement of weight or whatever, but we're dealing with measurement of what? Shapes. The next question will be, what kind of things can we measure out of shapes? We can measure their lengths, we can measure their breadths or widths, we can measure their heights or depths. So this is what we talk about when we are considering measurement. We're either measuring their lengths, breadth, width or height, width or breadth, or we're talking about the height or the depth. So what are the important things should we take note of? We said that we are measuring shapes. Stand out. So we have two types of shapes. Shapes can either be plain or they can be what? Solid. Shapes can either be plain or they can be solid. So shapes can either be what? Solid or plain. So we'll talk about plain, we refer to two-dimensional shapes. I will talk about solid, we refer to what? Three-dimensional shapes. So for a plain shape, it will have what? These first two. For a solid shape, it will have all of these. So to expand more on this topic, we're going to take on a little exercise and let's see how well we fare on this exercise. Okay, so we look at the activity we have on the board. It says list 10 plane shapes you know. List 10 plane shapes you know. So let's try that out quickly in the next 2, 3 or 4 or 5 minutes. Alright, we're required to name 10 plane shapes you know. So I don't know what your own listing had been, but I'm going to try to take us through this listing and you'll be amazed that you can name way beyond that. Number 1, we have what is called a circle. And there is an approach I'm going to take. I'm going to give a subheading and a title rather, and then list other shapes that we can find in there. Now look at this. Number 1, you could have a circle, you could have a sector, you could have a quadrant, you could have a semicircle, and you could also have a segment. So you see that you have so many shapes you can name under the category of a circle. Number 2. Example number 2 will take us to something we call polygons. These are things we've already studied in grade 8. Polygons. So we could have a triangle. So triangle is an example of a plane shape. Number 3, we have what is called a quadrilateral. A quadrilateral. And here, oh my, you have lots of examples. You have your square, you have your rectangle, you have your trapezium, you have your parallelogram, you have your rhombus, and you have, last I can think of is your kite. Your kite. These are the basic shapes you can have here. There could be other ones, but these are the ones I can readily lay my hands on. The next one we have is your pentagon. The next one you have is your hexagon. The next one you have is your heptagon. The next one you have is your octagon. The next one you have is your octagon. The next one you have is your nonagon. The next one you have is your decagon. Sometimes you could have things like decagon, which is 11, and duodecagon, which is 12. So you see that you have a total of 11 listing, close to 20 shapes that are plain you can list. So whenever you're told in an exam, list 10 plain shapes, you should be able to name at the least 10. So you have lots of shapes you can. Under triangles, you have different triangle types. I didn't talk about that, but you can also be sure to get that right. And so we go to the next aspect of our discussion. Okay, here goes the second activity. It says list solid shapes you have studied. In going into talk about cylinders and cones, you must be able to identify what are plane shapes. You know that these shapes are plane. But more importantly, you should be able to identify shapes that are solid. So the next aspect of our discussion will now focus on us trying to identify solid shapes. Alright, so we will now do our listing. Number 1 is a cylinder. Number 2 is a cone. Number 3 is a cube. Number 4 is a cuboid. Number 5 is a prism. Number 6 is a pyramid. Number 7 is sphere. So maybe we'll stop at 7. There could be others, but we'll stop at 7. So these are examples of solid shapes. But it's not just to list them out that's important. You should be able to do what? Identify them. You should be able to do what? Identify them. So our focus today is to try to look at the matter of cylinders and cones as it applies to mensuration. Now, just a quick note here. Every time we talk about a solid, there are two major measurements you can take from them. It's either you are measuring the area or you are measuring the volume. So let's see how this is done. Okay, what we have on the board, there are two diagrams showing us one, a rectangle, traditional rectangle. I'll just put 90 degrees here just to tell us that this is a traditional rectangle, and I have here a cylinder. The net of a cylinder is a rectangle. What that means is that if this were to be my rectangle and I decide to fold it like this, what I'm going to obtain will be a cylinder. I see it, an open-ended cylinder. So this geometry is my favorite aspect because I don't need to memorize any formula. In fact, the greatest mistake you would make in an exam is to give me a sheet of paper for geometry. With just this paper, I'll be able to generate any formula at all. So that's why we're going to be using this approach. So when you fold this paper, what you obtain is a cylinder, the curved surface of the cylinder. Exactly. Alright, so we will go straight to the board and make a statement. The net of a cylinder is a rectangle. That's in bracket the surface area. Surface area is a rectangle. That's the extension of that. Surface area is a rectangle. Alright, so with that said, we will then use these ideas now to look for the area or get formulas for area and get formulas for volume. So let's take this area of a cylinder. Area of a cylinder. Now when we talk about the area of a cylinder, it's important to note that you have three different areas you can look at. You can look at the surface area, you can look at the area where one end is open, and you can look at the area where the cylinder is totally closed. So we're going to look at one. So let's take the one after the other. Surface, or suppose we call it curved surface area of a cylinder. The curved surface area of a cylinder. Now what is area? Area is simply what? Length times breadth. If we consider our rectangle here, this is my prop for this. The length times the breadth will give you the area of a rectangle. So the area, area of rectangle will be equal to what? Length times breadth. But recall that we have said that the net of a cylinder is the same, the net of the cylinder is the same thing as the area of the rectangle. So when I roll this rectangle to become a cylinder, what I'm going to have will be that the side that used to be breadth before will become what? Height. Are you seeing that? That's why I made this marking. The side that was breadth before will become height. So if I fold like this, what you're going to see will be what? Height. So B, the breadth becomes height. Now, the part that was length before will now become what? C. And what is C? Circumference. So we'll have that the area, or the curved surface area, of a cylinder will be equal to the length times the breadth, which will be equal to the circumference times the breadth, which will now become the height. What is circumference? The circumference of a circle we know to be what? 2 pi r. Multiply that with what? H. So this becomes what? 2 pi r h. So you see that formula you've been trying to memorize right from the day you were in late upper primary till date. It's actually something you can derive with just a sheet of paper like this. Rectangle, rolled, folded, and the base becomes the height, and then the length becomes the circumference. It's the same thing. Instead of becoming a straight line, there are two types of line. There are straight line and curved lines. This straight line becomes a curved line, and this curve it has formed will be the shape of a circle. And what is the circumference of the circle? To be what? 2 pi r. So that said, the curved surface area of a cylinder becomes what? 2 pi r h. There's yet another condition where the cylinder area of cylinder, if closed at one end. Now take note of this. If a cylinder is closed at one end, the implication is that it is opened at one end. That's it. If a cylinder is closed at one end, it means the other end is open. So sometimes in the exam, they may not tell you closed at both ends. They may just tell you, they will not tell you open at closed at one end. They could tell you open at one end. So let's take an example of that kind of shape now. Okay, try to get a prop that would suit the description I'm trying to make. This is not a perfect, if we imagine that this extension is not there, and we imagine that this is perfect, this is an example of a cylinder that is opened at one end. See it? I can put my finger through here. So it's opened at this end, and it is what? Closed at this end. So this is an example of a cylinder that is opened at one end and closed at the other end. In looking for the area will be this curved surface I'm seeing that I'm rubbing around, and this part that is closed. So those are the things that will form the area. The area of this is a circle. This is a circle, so I know the area of a circle as pi r squared. And then the curved surface area of this part will be what? 2 pi r h. So with that, we can go to the board and establish a formula for that. Okay, so that will mean that area, if cylinder is closed or opened at one end, will now be what? 2 pi r h, which is the area of the cylinder, the curved surface, plus pi r squared, which is the area of this bottom part here. Right? So that is it for the area of a cylinder if one end is open or closed. So what happens if both sides are closed? So we call that the total surface area. Anytime you hear the word total surface area, the implication is that both sides are closed. So total surface area, the total surface area of a cylinder, or sometimes you can see in books they will tell you, which implies area of closed cylinder. So they don't tell you total surface area, they can tell you area of a closed cylinder. It's simply going to be what? I'm going to have 2 pi r h, which is the area of the curved surface like this. And then if it's closed at both ends, it means that I won't be able to put my finger through the top, and I will not be able to put my finger under. So I have 2 circles. So that will be plus 2 times the area of a circle, which is pi r squared. And this will become the formula for solving the total surface area of a cylinder. Generally, volume of any shape that is solid, is given as base area times perpendicular. I see this sign here. This is what we call perpendicular, a vertical resting on a horizontal. Perpendicular height. The kind of height we use to calculate volume is what we call the perpendicular height. What then is perpendicular height? Let's use this wonderful illustration. If I have a vertical line and I have a horizontal line, 2 perfectly placed lines in their behavior, what the relationship between this very vertical and this very horizontal is what is called perpendicular, and the angle that will be formed there will be what? 90 degrees. So the base area times the perpendicular height gives us an idea of the volume. So for a cylinder, volume of any cylinder will be equal to, using our model once again, the base area will be a circle. So it will be what? Circle or circular base times perpendicular height. Not just any height. And in mathematics, we represent perpendicular height by the letter H. So in geometry rather, in mensuration to be more precise, we use small letter H to describe perpendicular height. So what's circular base? Circular base will suggest that it is a circle. So the area of a circle is what? Pi r squared times H. So the volume becomes pi r squared H. Alright, that's the size of the class this morning. In our next meeting, we're going to be solving problems. By way of recap, we tried to look at plane shapes today. We tried to look at examples. We looked at solid shapes. We looked at examples too. Based on the examples we gave, we now focused on the matter for today, which was cylinder and cone. But we then narrowed ourselves to what? Just the cylinder. And we looked at area. We said there are 3 types of areas you consider when considering a cylinder. We have what is called the curved surface area. We have the area that has to do with one end of the cylinder open. And then we have what is called the total surface area of the cylinder. And added to that, we count it up with the volume. If you look at this shape here, this is the base area. Base area is circular times this height, which is straight, and we called it what? Perpendicular. And with that, we're able to get the formula for the volume of a cylinder. I trust you've enjoyed the class, and then this is where we'll sign out. Mamu Ujabis will return. Thank you.